Hi everyone, welcome to the low temperature thermochronology course. In Chapter 8, Application of Thermochronology in Petroleum Exploration, 3 sections will be discussed, including petroleum generation and paleotemperature recovery, paleogeotemperature evolutionary history of source rocks of the Earth basin, Mesocenozoic cooling history of the Weber uplift Earth basin. Today, let's have a look at the first section. 5 topics will be discussed, including petroleum generation and paleotemperature, petroleum accumulation and exploration, cooling history of rocks, habitat fission track dating of detrital rocks, modeling using the habitat fission track program. The organic material in a sedimentary basin is controlled by the paleotemperatures. Greater depths of burial are accompanied by increases in heat, which causes the organic matter to gradually transform into an organic matter, kerogen. The kerogen continues its evolution and changes in turn as heat increases, resulting in petroleum compounds that are generated, yielding bitumen and petroleum. Increasing thermal maturity also causes initial compounds to undergo structural simplification, commencing with oil, then wet gas, and ending at dry gas. For habitat, fission tracks are totally annealed above 110 centigrade and partially annealed between 60 and 110 centigrade, defining the partial annealing zone (PAZ). This temperature range overlaps with the temperature required for petroleum generation, making habitat fission track dating analysis well suitable for research of oil gas generation. From this figure, we can see that estimated petroleum generation zone with respect to paleotemperature indices and thermochronology meters. Values for each parameters are approximate because they vary with organic matter type, mineral composition, heating rate, and duration. Burial history with uplift cooling processes also affect the mechanism of oil and gas generation, migration, accumulation, and even transformation to reaccumulation. The timing and degree to which a sedimentary unit has been heated after deposition and cooled afterwards are important for several perspectives of petroleum resources, including assessment of source rock potential, reservoir classification, traps identification, reserve evaluation, and well planning. So, thermohistory recovery of rocks is a fundamental step for petroleum exploration and assessment. Habitat fission track dating of detrital rocks is very important for numerical modeling and geological interpretation for petroleum exploration. Traditional habitat fission track dating for rocks in petroleum exploration plays requires that samples have a statistical uniform population of habitat grains with similar thermal annealing behavior and single grain edges that pass the chi-square test. More track retentive populations can be modeled if corresponding kinetic data are available. Problems can be encountered when trying to apply fission track methods to the study of detrital habitat in sedimentary basins. Such habitat can be derived from multi-source areas with different pre-depositional cooling histories and with variable chemical composition. These factors can all contribute to discordant grain age distributions when the variance of the grain ages is greater than the expected and failing the chi-square test. This is particularly common for detrital samples from sedimentary basins that have had long residence times in the partial annealing zone. Nowadays, software for fission track dating include HIFT, density plotter, radial plotter, helioplot, binom fit, aft-south, QT, and Petroleum. For samples with discordant habitat fission track grain age distribution, it can be useful to display single grain ages according to their relative precision on a radial plot, and use the software such as binom fit or radial plotter to resolve different statistical age populations. On a radial plot, the most precise ages plot closest to the age axis, whereas low precision ages plot close to the origin. Binom fit was developed for fission track data obtained using the EDM, whereas radial plotter can also be used for data acquired using the LASAP-MS method. In addition, single grain ages can be displayed with respect to their corresponding kinetic parameters value on a simple XY plot, so that interpreted kinetic populations can be compared with the age populations from modeling. This type of analysis can help to determine whether the different age populations within a sample are mainly the result of differential annealing of multi-kinetic habitat grains or due to variations in provenance. From this lesson, we can see that thermochronology is very useful for petroleum generation, accumulation, and exploration. More attention should be paid to the exhumation, cooling, erosion of sedimentary basins when dealing with petroleum exploration. That's all for this lesson. Bye-bye.